In the previous video, we derived the equations for measuring the temperature with an NTC thermistor using a voltage divider and a beta model, and in this video, we will look at the C-code implementation of those equations and display the temperature in a terminal. Before we do that, let's see the hardware setup. Here we have an ESP32 microcontroller, and here we have a voltage divider that consists of a resistor in the upper branch and an NTC thermistor in the lower branch. The divider is supplied from the microcontroller's 3.3 volt supply pin, and the output of the divider is connected to the microcontroller's analog input pin labeled as D34. On the right side, we have the 4 parameters we need to determine before we look at the code, so let's do that. We know that Vs is 3.3 volts and the multimeter measured RT as 4.64 kilo ohms. In the datasheet of our thermistor, we can see that RT0 is 4.7 kilo ohms and beta is 3977 kelvins. Now that we know all 4 parameters, we can start looking at the code. Keep in mind that I will not explain the entire code, but just the thermistor temperature calculation related code. I assume you know how to use the ADC of your microcontroller. Okay, so first of all, we need to include the mat.h header file so we can use the natural log function for temperature calculation. Next, we define the values for Vs, Ru, beta, RT0 and T0. The unit conversion macros are not mandatory, but they help improve code readability. Here we have the ADC init function and the ADC get voltage function. Their implementation will differ depending on the microcontroller being used, so I won't spend time explaining how they work. This is the get temperature function. It consists of 4 steps. First, we get the voltage divider output voltage using the ADC. Next, we calculate the thermistor's resistance. After that, we calculate the temperature. Finally, we convert the temperature from kelvins to degrees Celsius and return the result. Notice that I personally prefer to put the unit at the end of a function and variable name. I don't do the same for macros because I can simply hover over them and see the associated unit written in the comment. In the main function, we initialize the ADC and periodically print the temperature. We also use a counter to keep track of the number of measurements. Let's run the code and see what we get. As we can see, the temperature is around 23 degrees Celsius. This matches what the multimeter shows, which means we are measuring the temperature correctly. That's it for this video. Thanks for watching, and I hope you found it helpful.